What's good, everybody? My name is Mr. Peters. Today's video, I'm going to do a complete review on rational and irrational numbers and what the difference is between the two. So, when we're talking about irrational numbers, guys, I'm going to give you some very important details, all right? So, irrational numbers will never be whole numbers. And they will never be perfect squares. All right, so let's establish that real quick. If you see a whole number or a perfect square, such as a square root of 25, the square root of 100, those are rational numbers. An irrational number is an imperfect square. So imperfect squares are something like the square root of 2, the square root of 101, and the square root of 3. All right. Another example of irrational numbers would be pi. All right. So pi is an irrational number. Why? Because when you put it in decimal form, irrational numbers do not repeat and irrational numbers do not stop. So if you have a decimal that's just continuing on or a decimal that is not repeating, that is an irrational number. Okay. And I'm giving you guys some more examples of irrational numbers. And they're typically the same. So pi is going to be one of the main ones you see. And like I said, anything that's an imperfect square, like the square root of 7, these are all examples of irrational numbers. 0, that's a rational number, just to make sure we clarify, okay? Now, on the other hand, we have something that's called rational numbers. And I want you to know that rational numbers are whole numbers. So if it's a whole number, it is rational. All right? So we have whole numbers and perfect squares. So if we have a perfect square, that is a rational number. So we're talking about 25, radical 36, or square root 36, the square root of 49. So these are some examples for you guys to see of rational numbers. I'm sorry. Now, when we come to like the fraction part, please understand, guys, that like something like 4 over 2, it's a whole number. That's rational. 1 over 2, as a decimal, it stops, right? It's just 0.5. So decimals that stop, those are rational numbers. So 1 over 5, 1 over 2, which is half. 3 over 4, which is 0.75. 4 over 5, which is 0.80. If you look at it, those decimals stop. So these are rational numbers. Now, when we're talking about decimals that just continue, and they not necessarily continue, but they repeat, we're talking about 1 over 3, which is 0.333. That's a repeating decimal. So this would be a rational number because the decimal repeats. Another good one is 2 over 3, 0.666, right? This is another example of what we will call a rational number. And I'm going to give you at least one more example of it, okay? So another rational number is something like this. And this is how they try to fool you. They'll give you a square root. They'll give you a fraction, and the fraction they're basically asking you for the square root. And automatically students normally think that it's irrational. But I want to challenge you guys, try to simplify it. Is it possible to simplify? If they were not perfect squares, then yes, it would be irrational. But when we look at this, this is just 4. And I'm sorry, I made a small mistake. This should be 25. I'm sorry. So this should be 4 over 5. And like we said, right, that's just 0.80. So this would be a rational number. But before we go today, I also want to give you guys some more helpful tips. So number 1, you guys should know that rational is represented by Q. So when we're talking about rational numbers, the abbreviation is Q. Irrational numbers, the abbreviation is going to be an I. And I want to talk about three other types of real numbers as well before we actually wrap it up today. And what we're going to talk about integers, whole numbers, and natural numbers. So let's just write that out. So we got integers, and integers is represented by a z. So if you see z, that means integers. So these are all the positive and negative whole numbers. So we're talking about -2, -1, 0, 1, 2. So for a number to be considered a integer, it has to be a whole number. It cannot be a decimal. If it's a decimal, it's not an integer. Okay? And it could be either positive or negative. And the way that they try to trick you is integers can be fractions, but the only way that it could be a fraction is if when you reduce that fraction, the answer is a whole number. So if you see 4/2 or -4/2, once we simplify that answer to just 2, that is considered an integer. So please just try to make sure that you try to look at the fraction and see if you could simplify it to a whole number. If you can, that means it's an integer. And then what we're going to do, I'm going to give you guys a very helpful tip on whole numbers, right? I'm going to write the abbreviation, and natural numbers. And they are the same exact thing except for one very, very, very tiny rule. And this is the rule. I'm sorry. I'm not going to get to the rule first. So what you guys need to understand and know is that whole numbers and natural numbers are only the positive whole numbers. So that means 1, 2, 3, 4, 5, and so on. So whole numbers and natural numbers will never be negative, right? They'll never be negative. They'll never be a decimal, and they will never be a fraction unless that fraction could reduce to a whole number, like 4/2 in our previous example. And the only difference between the two of them is that natural numbers does not include 0, and whole numbers, 0 is included. So please don't forget that very helpful tip when you guys are classifying numbers. And what I want you guys to also understand before we go is if a number is irrational, it cannot be rational, integer, whole, or any of those. If it's irrational, that means it's just irrational by itself. However, if it is rational, it's very possible that it can be rational and also be an integer, whole number, natural number. Okay? So thank you guys so much for joining us today. If you have any questions on this topic, please leave us a comment in the comment section. We'll definitely get back to you. And if you found this breakdown helpful, we're going to ask that you subscribe to our channel and smash the like button for us on your way out. I'm Mr. Peters. Thank you guys so much for joining us today on our real number system video. Thank you.